All right. Welcome to Nedia's Enterprises Product Showcase Fountain Creek Watershed Restoration Project, a case study on bioengineered streambank stabilization techniques with presenters Sibi Pothin and Dan Barr. Sibi is the CEO of Nedia Enterprises Incorporated. During his last 25 plus years, Sibi has collaborated with numerous engineers, landscape architects, erosion control specialists, and soil scientists, policymakers, contractors, and distributors to design, manufacture, and promote biodegradable products and solutions to soil erosion problems. Dan Barr is a water resource engineer for Matrix Design Group Incorporated. Dan has more than 40 years of water resources experience in both the public and private sector and has worked with various local, state, and federal jurisdictions and agencies. It's a pleasure to have you here, Sibi and Dan. I will now pass the mic over to you guys.
All right. So everyone should be able to see our first slide on our
presentation. It looks great, Dan. Go for it.
Okay. Well, I won't go any more into describing who we are. I was on the projects we're going to be talking about today. I was the project manager and the engineer of record on a project we call Barr Farm because the property is owned by Dr. Barr, a veterinarian in the area. It's not advancing my slides. There it is.
There you go.
So the project sponsor was the Fountain Creek Watershed Flood Control and Greenway District. We've done a number of projects for the district in the watershed. Matrix was the lead designer. We work with THK Associates as our landscape architect. The general contractor was Sun Construction. The landscape contractor was Total Terrain, and Nedia Enterprises provided large quantities of erosion control products, as you're going to see. Fountain Creek Watershed is about 930 square miles in the south central area of Colorado. It is tributary to the Arkansas River near Pueblo, Colorado, and extends to the top of Pikes Peak, almost and change in elevation of 10,000 feet. The city of Colorado Springs is a significant portion of the watershed, includes about 22% of the area, and has modified the hydrology in the creek because of return flows and increased runoff. The location of the Barr Farm Channel project is shown there in the lower portion of the watershed. These are the two reaches, the phase 1 and phase 2 of the project that is located between I-25 and Overton Road in Pueblo County. You can see the proposed design alignment in the orange and the red, and then the underlying pre-project alignment in the light shades of how the channel had realigned itself. This stretch of the creek is susceptible to flash flooding and is very mobile. It has a very mobile bed of sand and small gravel. This is some of the pre-project conditions. In places up to a 30-foot high embankment had eroded because of the migration of the creek. Utilities, where you can see the line of electrical power poles there on the left side, and some gas lines were also exposed because of the migration of the creek. So some of the key design parameters were: we need to pass a 100-year flow of over 33,000 CFS with velocities of 15 feet per second. And a key design flow was the 5-year flow of 7,000 CFS and the bank full flow of 2,900 CFS. Shear stresses for the 100-year flow approached 2 pounds per square foot. And the scour depth we designed to was about 8 feet for the 100-year flow. So Sibi's going to talk about some of the options for erosion control fabric that were available for the project.
Right. Thanks, Dan. That was a great introduction of the project. So as Dan mentioned, the design parameters are pretty tough, and we needed a high performance erosion control product to meet these needs. So I just want to list the requirements in here. So number one, the Fountain Creek watershed, they wanted the product to be a 100% natural biodegradable product and hopefully a renewable resource product. Number two, due to the semi-arid environment, the revegetation, the establishment of the vegetation was kind of difficult. So it takes several growing seasons for the vegetation to take root. So we wanted a product that would last like 3 to 6 years at least to allow the vegetation to get established. And the third requirement was that since we had a lot of the sand-laden flow, the product we use need to withstand the abrasive forces of the sand-laden flow. And the fourth requirement is obviously the design parameters, such as the flow velocity, 100-year flow velocity is 15 feet per second, and the 100-year shear stress is 2 pounds per square foot. They're pretty high numbers. And the fifth requirement is moisture absorption to help with the vegetation growth. And the sixth one is that the product needs to trap sediments because there are a lot of sediments in the flow. And finally, it has to be economical and easy to install. So based on these requirements, Dan and his team looked at a lot of products, and they finally came down to the conclusion that the CoreRap 1200 meets all the requirements, and it was selected for the project. So I just want to run down the spec sheets on this slide. As you can see, in the middle of the spec sheet, the water absorption is 146%. That meets the specs. The shear stress is 5 pounds per square foot. It exceeds the 2 required. And the water velocity is 16 feet per second versus 15 required on the job. And functional longevity is 4 to 6 years, which is more than the 3 to 6 years required for the job. And in terms of the sediment trapping, this product being a double-layered fabric with a jute inner layer with a very tight weaving that absorbs the sediments very well. So essentially, the CoreRap 1200 is a double-layered product with a outer layer of woven coconut, inner layer of woven jute. And it comes in a width of 13 feet. The way we used to do the product before was to use one layer of woven fabric and an inner layer of a non-woven blanket. So the disadvantage there was that the woven fabric comes in typically 13-foot widths, and the non-woven comes in like 8-foot widths typically. So different widths, different lengths. You need too many staples, too many splices. So it is a lot easier to work with this single product with double layer with uniform width. And the next slide here just talks about the different attributes of core netting. It's natural, biodegradable. There's a very high lignin content. So lignin is basically, down the next slide, please, Dan. The lignin basically is the glue-like material that binds the cellulose fiber in natural fibers. So the coconut fiber has about 46% lignin, which is the highest of all natural fibers, which explains why it's very hardy, very tough, has high tensile strength, and lasts 3 to 6 years. And also the coconut fiber absorbs water, and it absorbs solar radiation, and provides an ideal microclimate for the vegetation growth, and eventually decomposes into a humus-like material, adding nutrients in the process. Next slide, please. So in summary, this Barr Farm project used several stabilization techniques. The number one being the CoreRap 1200. They used that for all the soil lifts and for all the high flow areas up to the 5-year flow mark. And above the 5-year flow mark, we used the stitched coconut blanket with the BioNet C400B. And we also used large wood structures and seeding, both riparian and upland. And we used willow stakes for the revegetation of mostly the soil lift areas. And it worked out very well. Back to you, Dan.
Right, so bend protection on the outside of the bends was a key design element here. As Sibi just described, the foundation of the bank protection was large toe wood structures, and then a combination of the erosion control fabric and then natural vegetation that would come in to stabilize the system for the long term. So this is an overview of phase 2 of the project. Shows the color coding for the different treatments. Yellow was the upland seed with coir wrap. The green is riparian seeding, which is down closer to the available water supply. It's a different seed mix. And then the willow stakes are shown in the blue, and cottonwoods poles were also used in the orange shaded area. So just some general overall quantities for the project. The overall cost for both phases was about $10.25 million. Overall channel alignment involved 11,000 linear feet of the channel. About 22,700 linear feet of soil lifts were installed. That's using the coir wrap 1200, and I'll show you that detail in a little bit. 197,000 square yards of additional coir wrap was used up to the 5-year level. That was to address flows that would exceed the bank full flows. They were frequent enough to need protection, but not too unusual to see in the creek. And then in the upper areas, we put in 32,400 square yards of the coconut blanket, and this would be above the 5-year level. Total about 53.8 acres of seed and soil conditioning that was underneath the erosion control blankets. The total of 1,800 toe wood logs were used, 191,500 willow stakes, and 967 cottonwood poles. So to talk a little more in detail about how this was all installed, the foundation logs were basically a lattice work of foundation logs and top logs pinned together with rebar. The root wide logs laid on top provided some roughness out towards the channel side, and they were set 15 degrees into the direction of flow. Structure was embedded into the embankment about 26 feet, and the logs were minimum size of 12 inches in diameter. The toward structure provides the long-term bank stability, which underpins the soil lifts that go on top. This is a detail of the soil lifts. We used 2-tier and 3-tier soil lifts, about 1.25 feet in height, and the soil wrap extended about 6 feet from the edge. The lifts were placed in the bends with a little bit higher elevation to account for super elevation on the water surface. Soil compaction was placed at 95% of standard Proctor, and there was a soil amendment that was tilled into the front edge and top of each lift to facilitate growth of the seed. So this is a picture of the completed soil lift with willow stakes that provide additional stabilization. As Sibi mentioned, the fabric provides stability for the 3 to 6 year period while vegetation is being established. The willow stakes were installed both between and on top and through the soil lifts. And the soil lift was, like I mentioned, 1 foot above the bank full flow. Again, as Sibi described, the coir wrap 1200 had certain characteristics that were really beneficial to this installation. Biodegradable, had a high strength to withstand the shear stresses and the abrasive sand-laden flows in the creek. And the underlying woven jute layer provided constrained for the bank soils and protects against sunlight and also retains moisture. So this is a typical detail for installation of the fabric, trenching on the sides, use of 2-foot long wooden wedges, and that's pretty typical installation. So the CoreWrap 1200 was installed over the riparian seed up to the 5-year level using the wooden wedge stakes. And the coconut blanket C400B was installed above that level in the upland areas. So here's some pictures of the post-project conditions. This is about 4 months after installation. The vegetation was installed in the spring, and this was taken about August. So we got a pretty good start of growth in that first year. So thanks for your attention, and appreciate the opportunity to present our project.
Thank you very much.
And guys, we do have a couple more minutes here. If you want to answer, it looks like we had a couple questions come in. I think we only have time for 1 or 2 of them. One of them is, how do you prove 4-year functional longevity? What ASTM equivalent test is suggested?
That'd be for the fabric.
I assume so, yes.
Yeah, it's the 4-year, the 3 to 6 year longevity is basically known through field experience. The longevity depends on a lot of factors. Depends on the environment, depends on the moisture content, the humidity, the soil pH, a lot of factors that are affected. There's no ASTM test to really calculate that, basically field experience. And one thing we found is that if the fabric is exposed to water, if it's underwater all the time, it lasts longer. And if it's exposed to the air, not underwater, it also lasts quite some time. When you have recurrent wet and dry variations is when it increases the biodegradation. So essentially in coir, biodegradation happens due to microbial action. So when you have microbes acting, quicker and faster, the degradation happens faster.
Awesome, thank you, Sibi. I think we have time for one more question here. Was there other funding used for the project besides the landowner?
This was funded by the watershed district completely. The landowner didn't contribute any funding for the project.
Okay, awesome, guys. Well, with that, I guess we can close this out, but I know Sibi and Dan, and I think Roy as well, will all be in their booth space, which is booth number 1. If you have any questions or if you want to keep the conversation going. We do have a few we actually have a good amount of education after this, so we have to wrap things up, but I want to give a big thank you to Dan and Sibi, and as well as Nedia for your continued support at the conference. Thank you guys so much. If you have any questions for Sibi or Dan and Roy, again, Nedia booth number 1, they'll be there answering any questions, utilizing their video chat feature, which if you haven't tried that out yet, guys, it's a pretty cool feature that we offer in the expo hall, so I recommend doing so. Again, this presentation was worth half a professional development hour. And just so you guys know, for all of our vendor showcases, there's no coupon code required to claim your credit. All you need to do is just complete your course evaluation to do so. If you have any questions about that, just email someone at IECA and we can help you out. Have a great rest of your day, everyone. Thank you so much.
Thank you, Jack. Thank you, everyone.